Well, we're back again. We're getting started again. We all are meeting different challenges as we attempt to go through this lecture and understand what we're talking about. Thank you again for your commitment to being successful and understanding what everybody is going through throughout the world, throughout our nation, Michigan, and at OCC. Thank you again. Thank you from the bottom of my heart. So we're going to restart. Please keep in mind that we will be sending you an email. You should have received an email as to what accommodations and what support you will receive for these topics of study, because you can't ask me questions right now. Hence, I hope that you will pause it, try the problem first before I do it. You will want to pause it, try the problem first before I do it. Me just doing it is not going to be effective. You will want to pause the video, try it, and then attempt it, and then see what you did and what I did in terms of the problem. Let's resume. So we're on 5.1 continued. Then not working. Let's try this again. 5.1. Oh, really? 5.1 continued. We're looking at number 72. So number 72 says a negative 2x squared y to the fourth to the fifth power. And we might have done this problem in class. I'm trying to look at the screen at the same time as write. That's not being most effective, but we'll try our best and go from there. What we're going to do is we're going to remember our exponent rule tells us that we can pretty much put each one to the fifth power. So we'll have a negative 2 to the fifth power, x squared to the fifth power, y to the fourth to the fifth power. After we do that, we're going to actually use our exponent rules and actually simplify this more. Remember, if it's 5 or less, we must evaluate. So negative 2 to the fifth power is negative 32. Then that'd be x to the 10th, because we multiply when we have exponents. So whenever we have a to the m to the n, is going to be a to the m times n. And we went over that before we left. Then we have y to the 4 times 5, which is 20, and that is my answer. Let's try another one. Let's do number 76. Well, what does 76 say? Let's see. Oh, this looks like a bunch of crap. Let's try it. We have m to the third, n to the fourth, to the third power, over m to the third, n to the sixth. So, let's try this problem and see how we come out. We have, I'm playing around with the mouse, making sure that it doesn't go away. So what do you think we should do first? Well, we notice that this base right here is not the same as the base down here. So the first thing we need to do is get rid of our parentheses. So I'm going to take the third power to each one of those, and that becomes n to the third, and then n to the fourth to the third, over m to the third, n to the sixth. Now I'm writing it step by step. But after a while, I'm not going to write step by step anymore. We're going to have to step up our game and make sure we understand what's going on. M to the third is just m to the ninth. Remember, we're using our power rule. N to the 12th over m to the third, n to the sixth. Then we're going to use our quotient rule. So I'm going to go back up for page saving purposes. We end up with m. Quotient rule says we can subtract. I got 9 on top, 3 on the bottom. 3 cancel out. I'm left with 6. I've got 12 on top, 6 on the bottom, so 6 cancel out, I'm left with 6. Again, 9 minus 3 is 6, 12 minus 6 is 6. That's our quotient rule. Quotient rule reminder, a over m over a to the n is equal to a to the m minus n. That is our quotient rule. All right, so that we have that. Let's move on then. Let's try number 786. And again, I hope you are pausing this prior to me doing it, that you're trying it first and then I do it. So it says use the power of the quotient rule for exponents to simplify each expression. So we want to simplify this expression. Just essentially, it's called power over a quotient, and so we're sharing that 2 to everybody. Well, I'm going to shortcut it. No, I'm not. Let's do it. 7 squared g to the fourth squared over 6 squared h to the third squared. When we do that, we end up with 49 g to the eighth over 36 h to the 6. Miss B, how'd you get 36? Well, 6 times 6 is 36. So that's how we got that. All right, let's move on to 5.2. That's it for, that is it for 5.1. Let's move on then to 5.2. 5.2 is called the zero and negative exponents. The zero exponent rule says that x to the 0 power is 1. Essentially anything to the 0 power is 1. No matter what it is, if it's inside the parentheses, if it goes to the 0 power, it's 1. And the next one we have is what we call the negative exponent rule. And that is, it says x to the negative m is equal to 1 over x to the m, and 1 over x to the negative m is just x to the m. I like to liken this to being upstairs versus downstairs. If you're unhappy upstairs, you're too hot upstairs and you're unhappy, then you need to go downstairs. And if you're unhappy downstairs, it's too cold, then you need to go upstairs. And once you go upstairs, you feel much better. So let's go ahead and move on to the next page. And again, you can pause it, rewind it if I'm going too fast. Do what works for you. As we always say, do what works for you. So let's apply that to this one. If I had x to the negative m over y to the negative n. If you notice, x is unhappy. So since x is unhappy, where should x go? X should go downstairs. So it becomes x to the positive m. And if y is unhappy, where should it go? Well, it's downstairs, so it should go upstairs, which is y to the n. And so that is our answer for problems like that. I would like you to also notice another one. Let's look at x over y to the negative m. Well, we see this right here becomes x to the negative m over y to the negative m, which we know that they're unhappy upstairs, so they're going to go down. They're unhappy downstairs, so they're going to go up. So that becomes y to the m over x to the m. Well, we can actually just literally go straight to it and say this right here is equal to really y over x to the m, because the m is shared to both. So I can really just write this directly and say y over x to the m as my formula. Those two are equal. Is everybody with us? Yes or no? I hope you are with us. We're going to be on page 364. We're going to be on page 364. We're going to be on, what page are we going to be on? We're going to be on page 364. And we're going to be looking at number 16. We're going to be looking at number 16. And we're not going to be on 364. I apologize. That's 367. 367. We're going to be on page 367 looking at number 16. So let's try some problems. We're going to do, you know me, I love examples, so we're going to do quite a few examples to make sure you see what we're doing. I have 3/8 to the 0 power. Well, we know that anything to the 0 power is 1. Let's try number 20. Number 20 says 4 over 3a to the 0. Now, what's only being raised to the 0 power? A to the 0 is the only thing that's being raised to the 0 power. So that means that this becomes 4 over 3 times that 1 from a to the 0, which gives us 4/3. You got to remember what power, what is the power really on? What are we really exponentiating? What is really my base? Let's take c to the negative 4. And again, we want to make sure we write this in positive exponents. Well, what do we know? It's unhappy upstairs, so where does it need to go? It needs to go downstairs. And since there's nobody left upstairs, we got to have the air, which is 1. Let's go with number 30. Number 30. Negative 9 to the negative 1 plus 9 to the negative 2. Well, they're unhappy upstairs, so we're going to take them downstairs, and I get negative 1 over 9 plus 1 over 9 squared. Well, we know that 1 over 9 squared is just 1 over 81, yes? And in order to do this, in order to add fractions, we don't like them, but that's okay, we can handle them. In order to add fractions, we need a common denominator. So what's the common denominator between 9 and 81? Well, the common denominator between 9 and 81 is 81. We have to multiply the 9 by 9 to make 81. If I do it to the bottom, I have to do it to the top. And I end up with negative 9 plus 1 over 81, which gives us negative 8 over 81. All right, we're doing good. We're moving forward. We're almost halfway done. Let's do number 40. Number 40. Number 40 says, what does number 40 say? Let's move the mouse again so it knows that we're still here and we're still active. Number 40, negative 4 to the negative 2. Again, remember, what is the only thing that's moving? What is the only thing that's moving? That is the 4. Not the negative sign, but the 4. So that negative stays on top. The 4 squared moves on the bottom, and we'll have 1. Remember, if the power is less than 5, we must evaluate. So we end up with negative 1 over 16. Let's try another one. Let's do 44. I hope you are pausing and trying it on your own. I hope you are pausing and trying it on your own. Do not just sit there and watch me do it. You are not going to learn by osmosis. You have to try it. Let's take 6 over k to the negative 2. Again, I hope you are trying these before you do them. I hope you're trying them before I do it. Again, who's unhappy? K is unhappy where? Downstairs. So where's k got to go? Upstairs, exactly. So I'm going to have 6k squared, and that's it. Let's try 54. That's on the next page for those of you who have a written book, or you just go online, use your online component, and scroll down, and you'll be able to see it there. I end up with a over x to the negative 10. So we saw this earlier. We want to, the directions tells us to simplify. Well, we can do this two ways. We can raise the power first and then switch it, or we can go to what rule we have that allows us to flip it first. So let's do that. And I wanted to see if that rule, well, okay. So I'm going to do it both ways to make sure that we've got it. The first way is to say a to the negative 10 over x to the negative 10. I'm unhappy downstairs, I'm unhappy upstairs, so I get x to the 10th over a to the 10th. Or, and I'm going to do that in red, I'm going to do the or in red, and we see that we can have x over a to the positive 10, which gives us, again, x to the 10th over a to the 10th. I don't care which way you do it. Again, do it the way that works for who? You. So you want to make sure you're doing it the way that works for you. I'm not stipulating how you should solve these problems. Let's take 64. 64 is y to the negative 3 over y to the 4th. If you notice that when you have y to the negative 3 over y to the 4th, you can take that y to the negative 3 and bring it downstairs and use your product rule. Or you can use the quotient rule. The quotient rule says just subtract them. So I end up with y to the negative 3 minus 4, which is y to the negative 7, which we know is 1 over y to the 7th. So we have that also in our arsenal. I'm going to pause this just to make sure you have it, and then I'm going to keep going. We're doing good. We're moving forward. We're making moves. Let's do number 68. Again, you have the ability to pause, zoom, do all kinds of stuff as we go through it. So you do not have to feel like I'm going too fast. Just pause it, rewind, and see it again. Let's do number 68. Number 68, what does 68 say? It says n to the third to the negative 5. There are multiple ways to do this problem. I'm going to do it straightforward the way, of course, I'm going to do it the way that I'm looking at it. I'm going to multiply first, and I end up with n to the negative 15, which is just 1 over n to the 15th. There are multiple ways to do it. You could have pulled down and rewrote it. You could have done it this way. You went 1 over n to the 3rd to the 5th, and then said that's 1 over n to the 15th. It does not matter which way you do it. You're going to still end up with the same answer. Let's look at number 78. Number 78. My phone is going off the hook today. 78. I really miss y'all. It's not so fun when you're by yourself. 6 to the negative 2. And I like to have fun in class. B to the 9th. C to the 3rd. Oh, this looks like a bunch of crap. 5 to the negative 3. B to the 4th. And C to the 8th. And essentially what we want to do is our numbers first and each letter separately. So we're going to have to look at this, doing our numbers first, then each letter separately. The same way we talked about multiplying, we want to do our numbers first and then look at each letter separately. I'm trying to get it brighter if I can. I'm trying to get it brighter. I haven't figured out what's the best method for getting it brighter just yet. I'm working on it. Oh, that's pretty good. Let's see. Okay. All right. So let's go. Here we go. I'm going to take, for the numbers, I'm going to go this downstairs and 5 upstairs. So we end up with 5 cubed upstairs and 6 squared downstairs. Now, we have b to the 9th over b to the 4th. There's 9 up top, 4 on the bottom. You remember, do your fingers. We're doing our fingers. So we got 4 and 9. How many are going to cancel out? So you're left with b to the 5th up top. I've got 3 on top, 8 on the bottom, 3 cancel out, so I got 5 left on the bottom. Remember, canceling out. C cubed means C times C times C. C to the 8th means I got 8 C's on the bottom. 3 cancel out, I'm left with 5. Of course, remember that your numbers, because the powers are below 5, we're going to have to multiply them out. I get 125, b to the 5th over 36, c to the 5th. And guess what? That is my answer. Okie dokie. Let's try another one. Last one of this section. Let's do number 80. Number 80. What does 80 say? What does 80 say? Let's take xy to the 3rd power over x to the negative 1, y to the negative 1 to the 3rd power. Okay, let's do it. So when we raise this to a power, and I'm changing colors because the blue is getting on my nerves. So let's try a different one. What do you want to do first? We can simplify the inside and then 3 it, or we can 3 the whole thing and then simplify. I'd rather simplify the inside first and then raise my power on the outside, because it just reminds me of order of operations, working the inside and then the outside. Remember, please excuse Medea's Aunt Sally, my dear Aunt Sally, PEMDAS. So let's simplify the inside. I've got x to the 1 over x to the negative 1. Well, we know 1. If I did x to the 1 minus a negative 1, that becomes a positive. Be careful with that. So I end up with x squared. Be careful with that. Then I have 3. Y to the 3 minus a negative 1. We're using our quotient rule that tells us we can subtract our exponents. That becomes a plus. So I end up with y to the 4th to the 3rd power. Now I'm going to power each one using my power over product rule. And that becomes x to the 6th. Y to the 12th, and we're done. We are done with 5.2. Yay! Let's move on to 5.3. 5.3 is called scientific notation. You do this if you've ever taken a science class. How many of you have taken a science class since you've been at OCC? If you've taken a science class, you have done scientific notation. It's the first week of every science class. I teach it kind of weirdly, though. So go along with how I teach it. I like something. I don't like to tell me to move to the right, move to the left. It gets confusing. I want to know what essentially are we trying to do. And so I teach it a little weirdly. So let's do it the way that I'm teaching it. And I hope you're okay with that idea. Essentially, scientific notation enables us to change really large numbers or really small numbers to a form of some a times 10 to the n. Where a is a real number, where a is between 1, is greater than or equal to 1, but less than 10. So it's any number between 1 and 10, and n is any integer. So a is any number between 1 and 10. So that's 1, 2, 3, all the way to 9.99999. Any number between 1 and 10, that is your number. Okay. Let's go with, let's take 2 change. from scientific to standard notation. You know I'm a steps person, so let's write our steps and we'll have it down. So to change from scientific notation to standard notation, number 1, if n is positive, then the number is large. In other words, greater than 10. So if n is positive, then the number is large. In other words, greater than 10. So move the decimal point. Now, let me ask you a question. If I want my number, let's say I have 3.5, and I want my number to be large, will I move my number to the left, or will I move my decimal to the right? I hope you said to the right where we can add zeros. So I'm going to move my decimal point to the right in number of places. Fill in zeros as necessary. Number 2, if n is negative, then the number is really small. And we're talking about numbers that are like 0.0005, something like 0.000000000052. Something that's small, infinitesimally small, something that I need a microscope or some stronger form to be able to view it, like the size of an atom and stuff like that. So if n is negative, then the number is really small, and we're gonna move our decimal point. And I'm sure you can guess it. We're going to move our decimal point to the left in number of places. Again, fill in zeros as necessary. And so that is our method for changing from scientific to standard. Let's do a couple examples, and so we can be familiar with it, and then we'll move on to how to change it to scientific notation. So I'm going to change our paper, and we're going to move on to how to change it to scientific notation. Let's go with number 14. Number 14 says 3.75 times 10 to the 4th. Notice that the 4 here is positive. So since the 4 is positive, we're going to be going to the right 4 places. So to the right 4 places. Let's do that. We're going to take 3.75, go to the right 4 places. So that's 1, 2, 3, 4. And what do I need to add in? 2 zeros, exactly. So my answer is going to be 37,500. Very good, very good. Let's try another one. Let's try number 20 this time. We're going to do number 20. Number 20 says, what does 20 say? It says 7.63 times 10 to the negative 5. 63 times 10 to the negative 5. Then we're going to do, what are we going to do? We're going to do, since negative 5 is red, and I apologize, I went blank for a minute. I started thinking about something else. I apologize. Negative 5 is negative. We're going to, what? We're going to go to the left 5 places. So, we're going to write our 7.63 down, and we're going to go to the left 5 places. 1, 2, 3, 4, 5. Decimal point there. Fill in zeros. 1, 2, 3, 4. So my answer ends up being, and for those of you who like that 0 in the front, you can put it there. Sometimes I will and sometimes I won't. I'm going to remind you, sometimes I remember to put it and sometimes I don't. This is our answer for number 20. Okie dokie, let's do number 32. 32 gets into talking about scientific notation. So to change from standard notation, oh my goodness, I'm going crazy, I'm by myself in here, to scientific notation. Number 1, we're going to move, now let's circle it because that's what we did last time. We're going to move our decimal point to the immediate right of the first non-zero number. And put in parentheses, you read from left to right. Just put that in parentheses. I'll tell you why in a minute. Now we move on to step 2. The number of places moved equals n. So how many ever places you moved equals n. Oh, by the way, sorry, let's go back. This gives us, in number 1, this gives us our A. This is now our A. So when we move that decimal to the right of the first non-zero number, that number we get gives us our A. Then we're going to move the number of places we moved it is n. Step 3. If the original number was large, then that implies that n is positive. If, and remember, large number means more than 10. If original number is small, less than 1. If the original number is small, then n is negative. So if the original number is small, then that implies that n is negative. Alright, so let's do it. Let's look at number 32. Let's look at number 32. 32 says 290,000. And see if you can try it. See if you can pause it and try it using the steps that we have written above. So we have these steps written above. See if you can try it. But where is the first non-zero number? X marks the spot. It's not after the 9. I know you're looking at it from the right, and that's the first non-zero number. No, we're going to be looking at it from left to right. The first non-zero number is the 2, so we're going to put our decimal here. X marks the spot. Now, second question, where is the decimal when I don't see it? The decimal when I don't see it starts from the very end. So it's here, and we're moving it 1, 2, 3, 4, 5. When we move it 5 times, we end up with 2.9. Remember, the zeros on the end can really fall off, but if you want to put them back there, I don't care, but you really don't have to. It's unnecessary. Times 10 to some kind of 5 because we moved it 5 places. The question is the 5 going to be positive or is the 5 going to be negative? Well, remember, our original number was big. It was 290,000. That's quite a bit. So that means that because it's big, that means 5 is going to be positive. So our answer, if we want to make it look better, and this is not plus or minus, that's just a space, I guess you can say. Our final answer is going to be 2.9 times 10 to the 5th. Let's try another one so we can see what in the world is Miss B talking about. Let's look at number 40. Number 40 says 0.0001. Again, X marks the spot. We're going to find the decimal point right after our first non-zero number. Our first non-zero number is here. So we want to move our decimal point to right after our first non-zero number. And that is 1, 2, 3, 4. When I moved it 4 places, I end up with 1 times 10 to some kind of 4. The issue is, what kind of 4 is it going to be? Well, the number we started off with was small. It was like 1/10,000. It wasn't 1,000. It was 1/10,000th with a TH on it, which is 1 over 10,000. So that means that we're going to have a negative here because it was really small. So our final answer is going to be 1 times 10 to the negative 4. All right. Let's try another problem. Let's look at number 48. Why don't you try 48? You do number 48 and also try number 52, I would do. No, that's too much. That's way too much. Try number 34. I would do it, but I'm just going to do 48. Here we go. We've got 55. We want to write this in scientific notation. So here we go. X marks the spot. Where is X marking the spot? Right after our first zero number, which is here. Yes. And we're going to move our decimal point 1 place to get there. So that gives me 5.5 times 10 to the 1. And it's going to be positive because the 55 was bigger than 10. So I just get it with 5.5 times 10. Because 10 to the 1 is just 10. All right. Let's try. Now, we're going to combine this when we're able to multiply and divide in scientific notation. So we're going to combine this when we want to multiply or divide in scientific notation. So sometimes, like for example, I'm not going to want to do math with Bill Gates' money and have to write all the decimals out. I don't want to do that. I want to be able to sum it up and be able to do it to where we can figure it out. So let's take scientific notation. We're going to multiply and divide using scientific notation. Step 1. Change each number to scientific notation. Number 2, use exponent rules and divide or multiply. Step 3, change to standard. And if required, change back to scientific. Change answer to scientific. This keeps you from having to know whether if you move it to the right, is it going to go up or is it going to go down, or move it to the left, is it going to go up and down. So instead of having to deal with that, if you change it to standard notation and then go back to scientific, that pretty much sums up everything all at one time, and you don't have to worry about whether if I move it to the right or to the left, is it going to go up or go down. I will tell you that if when you move to the right, then you're pretty much saying I'm decreasing the power because you're having to move your decimal. If you move to the left, you're increasing your power because you're having to move your decimal those number of places. But I don't want to deal with that, and that gets kind of confusing for students, and I don't want my students to be confused in the least bit, especially since I'm not here. So let's try number 70. Again, I don't want to confuse my students. It says give my answers in scientific and standard notation. So if you look at the directions, it says give the answers in both of them. Let's take 169 billion. Over 26,000. No, that's not. That's 20. Excuse me. That's 26 million. Oh my goodness. Now some of you say, well, Miss B, I can just cross out the zeros right now, and I can just type it in my calculator. And why do I need to do all this? Because you need to learn it. So you need it for science classes. Because who wants to deal with numbers like this? I'd rather sum it up to make it a lot more easier. So the first thing we're going to do is change it to scientific notation. So let's change it to scientific notation. The first one gives me 1.69 because X marks the spot. And I wrote 1.99. Sorry. That's a 6. That's a 6. Sorry. 1.69. How many places am I going to have to move it to get there? Let's see. Well, that's 3, 6, 9, 10, 11. So I get times 10 to the 11, and because they're big numbers, I know it's going to be positive. Over 2.6. Remember, X marks the spot. I'm going to have to move it 3, 6, 7. So times 10 to the 7. So we're here. Now we're going to use our exponential rules or divide, just straight divide, to figure out the answer. So let's do that. And my smart self decided to start this without a calculator. What kind of foolishness was that? I'm doing this without a calculator. Recording without a calculator. That was not smart. I hope you are not sitting there trying to take notes without a calculator. That is not effective for neither one of us. Oh, okay. So let's do it. I'm gonna get, and I'm using my cell phone. You know, cell phones come in handy. Miss B, you be on us about cell phones. I know. Tell me about it. But I'm using my cell phone, and I'm gonna go get that app. You know, we talked about that TI-84 app that I'm able to use. Excuse my phone. Got text messages and stuff coming through. So here we go. Let's do it. So we're going to take 1.69 and divide it by 2.6. And I'm going to get 0.65. So that took care of my numbers. Now let's do our letters. Well, if we know on our 10 to the 10s, if we notice that they have the same base, can't I use my exponent rule, the quotient rule that says I can subtract? Won't that just be times 10 to the 4th? Yes? So I'm going to take that, times that by 10 to the 4th, and I get 6,500. I'm on step 3. This was step 3, changing it to standard notation. And now I'm going to change it back to scientific. So, 1, 2, 3, 6.5 times 10 to the 3rd power. Now, remember I told you that if you move it to the right, you're going to end up decreasing this by 1. And that's exactly what happened because we had to move to the right 1. Just in case you wanted to, for informational purposes. Alrighty, let's try another one. Let's do number 72. 72. 72 has point. So watch this. It goes 0.000000061. So that's 7 zeros times 3,500,000,000. Oh, this sounds like a bunch of crap, but we can handle it. It's no big deal. So now that we have that done, the first step is to change it to scientific notation. So let's do that. We get 6.1 times 10. And remember, we're moving it 1, 2, 3, 4, 5, 6, 7, 8 times. We're moving it 8 times. So that's going to be 8. But because our number was small, it's going to be negative. Times, let's see. X marks the spot here. So we're moving it 1, 3, 6, 9. So we end up with 3.5 times 10 to the 9th. You know, you talk about $3.5 billion. That's essentially what it is because 10 to the 9th means billion. So 10 to the 9th means billion, 10 to the 6th is million, 10 to the 3rd is thousand, 10 to the 12th is trillion. All those, that's what they mean. This 3.5, we're saying $3.5 billion, that 10 to the 9th means billion. Just for informational purposes, just throwing stuff out there. So what do you think I'm going to do first? I'm going to multiply my numbers first. How'd you know? So let's multiply. We're going to multiply 6.1 times 3.5. We are not doing FOIL. There is no addition or subtraction sign here. This is straight multiplication. Everything is being multiplied by each other. So I'm just going to multiply by numbers first. So I'm getting my handy dandy calculator and figure out what 6.1 times 3.5 is. And I end up with 21.35 times. And remember, the exponents What do we do when we multiply and they have the same base? We do the product rule, and that is add exponents. So I get times 10 to the positive 1, because negative 8 plus 9 is 1. But I want to change this to standard notation, and that's just multiply it out. Type it in my handy dandy calculator. Miss B, what you type? I type this times, see if we can get times, see if we can get this a little brighter. Well, as bright as it's going to go. Alright, so times 10, because I times it by 10 to the 1. So that becomes 213.5. So we move it. Here we go. X marks the spot. To change it back to scientific notation, that is here. So I end up with 2.135 times 10 to the 2. Again, moving it to the left. This time increases 1. Before we moved it to the right, this time we're moving it to the left. It increases it 1. So moving it to the left increases. And moving it to, and going back up here, moving it to the right decreases. Okay, just giving you a heads up, just adding information into that. I want to talk about what you see on your calculator if we're doing something really crazy. I want to look at, let's say I was looking at 2 to the 32. Oh, that wasn't a good one. Let's try 5 to the 32. We end up with something that says e to the 22. Whenever you see e on a problem, that mean in your calculator, that means times 10 to whatever number is afterwards. So if I see 2.328 blah 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 e to the 22, that's saying 2 blah 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 times 10 to the 22. So it's going to be times 10 to the 22. That's what e means on your calculator. Just a side note. Alright, I have finished 5.3. We will resume. I'm going to stop this recording on 5.3 because I don't want to lose it. And then we'll resume again 5.4 on the next recording. Thank you again for your understanding, and you will be getting more information as we go forward. Thank you again. Oh, you should be able to do your web assign now up through these points. You should be able to do your web assign now, assignment up through 5.3, up through scientific notation. Thank you again. Have a good day.